Hi, I'm Ben.
And I'm Sarah, and today we have some updates both on the code side and the D3 side for our current project. On the code side, we've actually parsed a large amount of the data that we got from eBird to put it in a usable format for D3 using a couple of different scripts and making sure that we have the bird outings and the bird sightings in the right place. And then on the D3 side, we've built some simple visualizations and demonstrated that we can actually take that data and put it into D3 using the D3 library. And just as a recap, we're building this for people who want to go out into the woods and find birds, and trying to really understand how seeing different species of birds together can help someone identify, predict what types of birds that they might see. So if they see a robin, for example, then this visualization will show them that they can also see, they're likely to see a sparrow or a blue jay at the same time.
So during our last update, we were having a really hard time actually digging into the data set that we got from eBird. Since then, we were able to open the file, filter out a lot of the unnecessary and redundant data that we didn't need, and simplify it down into a much more usable and smaller and compact file that's a little bit more efficient for what we need to export into D3 for the visualization. All right, so we retrieved our data set from eBird, which came in the form of a tar file, which we exported, unzipped. We opened it with Excel, we copied all the data, did a little bit of manual filtering beforehand, before importing it into a script file, which we could then do some more filtering on. It had over 42,000 individual sightings listed, which we were then able to export from this script file into two separate files that are subdivided into bird names, which is an array of 333 of the different species that we're seeing, and bird outings, which is these 42,000 sightings clustered into the 20,000 actual outings that each species was seen in. So these are our two final files that are referenced by our HTML file, which will have some scripts in it as well, that is using the D3 library to ultimately output this Chrome browser to display all of the connections and information visually.
We explored and evaluated different types of D3 visualizations to find one that best matched our data and our purpose. We landed on chord diagrams, which display relationships between data sets. In our case, a relationship between birds seen together on one habitat. Like all D3 visualizations, chord diagrams are SVG elements that represent connections in the data. As a first step to developing in D3, we built several simple diagrams for bar charts and scatter plots to understand how the language works together. There were a couple of challenges associated with this. One of them was the automatic caching, so it was really challenging to make sure that your visualization was updating as you changed the data. The second is that for any D3 visualization that references an external data set, you actually need to run a local web server to make sure that you can visualize that data in Chrome. Since we've already taken our sample data set and integrated it with our target visualization, our next step is going to be taking our complete data set and making sure that works with our visualization as well. Once we do that, we'll be able to experiment with some things like color, shape, line width, etc., to make sure that our visualization actually looks good and represents the data well. And finally, the third next step is that we're going to create a couple of web buttons and things like that that will enable us to filter the data on the fly so that you can see visualizations for different times of year like spring, summer, or fall.
So moving forward, our remaining risks are anything associated with unexpected hiccups that might arise from some of those last few details that we need to integrate together. But short of that, the only risk we foresee is if one of us were to get hit by a bus or catch avian bird flu.